Hello guys, I hope all of you will be fine. So from today we have been starting another course and that is related to the solution of the exercise problems of probability and statistics for engineers and scientists by Walpole. Okay, so this is basically the first chapter, which is the introduction to statistics and data analysis, and the exercise problem we have been going to solve today is basically 1.1. Okay, so what is it basically? So the following measurements were recorded for the drying time, okay, in hours of a certain brand of latex paint. Okay, so these are basically the samples. So what do we have to do? Assume that the measurements are a simple random sample. Okay, so these are basically the randomly collected sample, and what do we have to do? We have to answer the questions or the part of these questions which are from A to F. So what is A? So A is what is the sample size for the above sample. Okay, so the sample size here is, we have to count the number of samples. So there, these are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so these are the answer of part A. Is here we have the answers, and the answer of part A is 15. So the answer of part A is 15. Similarly, in part B, we have to ask it to calculate the sample mean for these data. So we have these data, and we have to find the sample mean for it. And previously I have shown you that what is mean by a sample mean. So if you want to find out a mean, what do we have to do? We have the data points which are xi, we have to sum them all and then divide them over the number of the items what we have. So here we have n equal to 15. Okay, this is basically n, so n is 15. And what do we have to do? I have to sum them all together. Let me sum them here, and summing them here, what I will get here, these, it would be 3.4 plus 2.5 plus 4.8. Okay, and up to the word, up to the final sample, which is here, this is 4.8, and we have to add them all together and divide them over what, over n, which is 50. Okay, so as I have done it myself, you can try it yourself it as well. So adding them together, what I will get, adding them together and then dividing it over 15, I will get 3.79, which is the what, which is the sample mean of my data. Okay, so this is the answer of part B. For part C, what do we have to see? Calculate the sample median. So what is the difference between mean and median? So mean is the average of the data what we have, while median is basically the midpoint on the mid sample. Okay, so to find out the median of our data, we should have to follow some steps. And what are those steps? So initially, what do we have to do? Steps are, first step is sort the data. Okay, we have to sort the data. So we have a data and we have to sort it, and then after sorting it, we have to write it. And as I have previously sorted as well, so let me write it here. So writing it here with this color, so let me write it here. So sorted data I have is 2.5, 2.8, 2.8, okay, 2.9, 3.0, okay, 3.3, this is 3.3, 3.4, 3.6, 3.7, okay. Similarly 4.0, this is the sorted data, 4.4, 4.8, 4.8, 5.2, and 5.6. So this is the sorted data. Let me count it, that these are 15 or not. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so these are basically 15 data samples, and now in order to find the mid of them, as we have 15, so the right side data points and the left side data points should be equally divided. Okay, so these will be equal in numbers, so therefore 7 will be at the right side of the midpoint or the median, and while 7 will be at the right side and 7 will be at the left side. So let me count them. So 1 2 3 4 5 6 7. Similarly 1 2 3 4 5 6 7. Okay, so as 15 is the odd number, therefore the midpoint here will be this 3.6. so therefore after sorting it, we have to find out what we have to. After sorting the data, if the number of points, if the number of data points, okay, are odd, okay, then median will be what? Median will be the mid number, will be in the middle. Similarly, the another case is if data is even. So what do we have to do then? We have to take two mid numbers, okay, mid 1 plus mid 2, and divide it over this 2, and this will give me what? This will give me median for our data. So now as we have only these, this is n is 15, so therefore the median for our data is what? The answer of part C is median is what? Median is 3.6. So this is what? This is the answer of part C. Okay. So these are all the parts what do we which I have solved so far. So now let me remove these parts. Okay. We have calculated mean, we have calculated median, and I have told you how to calculate them. After it, what is the next step? The next step we have will be the plotting the data by way of dot plots. Okay, so in plotting our data, what do we have to do? Let me have this black color. So this is part D, and here let me have this black line. Okay, so let me start it from 2.5. Okay, and here we have, let me have here 6.0. So from 2.5, let me have here 3.0, then 3.5, then 4.0, 4.5, 5.0, and here 5.5. So we have these ranges here. So now let me do what? Let me draw them here with this red color. Okay, so the first point we have is 2.5. Let me draw it here. So this is 2.5. The second one is 2.8, which is near to this one. So let me write it here. The second one is also 2.8. Okay, the third one is 2.9, which is here. Then 3.0, 3.0 is here. Okay, then 3.3, which is almost here. Okay, then 3.4 here. Okay, then 3.6, we have 3.6 here, 3.7 here, 3.7, 4.0, 4.0 is here, then 4.4, okay, 4.8, which is here, then 5.2. So let me have 5.2 here, and then 5.6. So what is this? This is the plot of our data, and we can see that this is almost uniformly distributed. All the data points are uniformly distributed here. This is the answer of part D. It is for up to this point that we have discussed this question, and today we are going to discuss part E and part F of our question. So the mean and median calculated previously has been written here. So what do we have to do today? So in part E, we are asked to compute the 20%, okay, 20% trimmed mean for the above data set. Okay, so what is mean by the 20% trimmed mean? So 20% trimmed means what do we have to do? We have to remove, if this is the overall data set. So let me have it. If this is the overall data set, so what do we have to do? We have to trim it 20% from the lower end and 20% from the upper end. Okay, so this is 20%, this is again 20%, and what would we have? This will be our data set, new data set now, which is 20% trimmed, and we have to find the mean of it. So this is the 20% trimmed mean. Okay, so the actual data set what we have here is this one. So this is the actual data set, and what we have, do we have to do? We have to trim the 20% of it. Okay, so the 20% of 15 is what? So the 20% of 15 is 0.2 multiplied by 15 minus 15. That would be what? That would be 3. Okay, so it would be 3. Okay, so what do we have to do? This is now here 15 into 0.2 is 3. So we have to remove the 3 numbers from the lower end. Okay, these are the 3 numbers from the lower end, and these are the 3 numbers from the upper end, and then we have to calculate the mean of it. Okay, so now we can see that how many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers. Okay, so I have to add these numbers. I will have to add them. So by adding them, I will get what? I will get X. Okay, so let me do it now. So let me choose this color for it. So trimmed mean, or let me do it like removing it. Let me remove it. Okay, and now let me calculate the trimmed mean here. Mean trimmed, that is 20%, and it will be what? I have to add all the data points from 2.9 plus 3.0 plus 3.3, okay, all up to this 4.8 plus 4.8, and now divide it over the number of the data points we have. So now the remaining data points we have are 9. Okay, so as I have already calculated it, and the trimmed mean now I will get is 3.68. This is what? This is the trimmed mean. Okay, so this is what? This is the answer of part E. So what is the last part? So in F we are asked that is the sample mean for these data more or less descriptive as a center of location than the trimmed mean. Okay, so we can see that both of these mean with when we haven't done the 20% trimming, and the mean when we have performed the 20% trimming are almost similar. Okay, we can see that these values are almost similar, so therefore these are not more descriptive, or these two are almost similar. Okay, so we can see that the sample mean for these data more or less descriptive as a center of location than the trimmed mean. Okay, both of these are similar, so these are the same. These basically possess the same level of descriptive information. So that's it for today, in which we have discussed the remaining part of our question. In the upcoming video we will talk about some more questions, and that will be the basis of the data analysis, which we will see in our course related to the Power BI, Excel and Python for the data analysis. And these things will be very helpful for us in our future analysis videos. So this is question 1.2 of our chapter Introduction to Statistics and Data Analysis. Okay, so the statement here we have is, according to the journal Chemical Engineering, an important property of a fiber is its vast water absorbency. A random sample of 20 pieces of cotton fiber was taken and the absorbency on each piece was measured. Okay, so the following are the absorbency values. These are the absorbency values. We can see that these are the values which have been obtained from the fiber. Okay, so what are basically the questions in part A? We have to calculate the sample mean and median for the above sample values. Okay, so this is part A. So let me start part A here, and here we have different values. So in order to find the sample mean, let me have here mean. And how can we calculate the mean? Mean will be the sum of the all data, okay, divided by the number of data points. So how many data points do we have? We have 20 data points, and we can also find it by counting the number of data points available here. So that is 20. Okay, and what are these values? We have to add them together. So 18.71 plus 21.41. So 18.71 plus 21.41 and up to the last value, which is here, this is 21.12, 21.12. So adding them all together and dividing it over the number of samples here, that are 20. Okay, so we have to divide it over it, and what would we get? We would get here the summation, and the summation here is 415.35 divided by 20, and it will give me 20.76. Okay, so this is what, this is the sample mean for the data set or the data which has been given. Okay, the second part of our question is or the second part of this part A is basically the calculation of median. So I have previously told you that how to calculate the median. So in median we have two steps. Number one is the sorting, and number two is finding the mid values. Okay. So now as we have sorted this data, let me write here the sorted data. Okay, so the sorted data, I have to write it here, and that would be, let me draw a line here. Okay, so let me draw this line here. Okay, so let me have here, this is what, or let me limit it to here, this is here as well. This is the first data point, this is the last data point, which is the 20. This one is the middle one, which is 10. This is 5, this is 15. Okay, similarly after it we will have here 4, 3, 2. This is here 9, 8, 7, 6, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so this is basically scale. Let me write all the values here. What are basically the values? So the lowest of it is, let me use this color for it, lowest of it is 18.04. okay, the second value here is 18.71. okay, this is 18.92. okay. After it we have 19.25, then 19.29, 19.44, 19.77, 20.17, okay, 20.33, 20.50, and 11th one is 20.72. 12th one is 21.12. Okay, and then 20.41, 21.77. Okay, then 21.81. Okay, 22.11, then the 22.43, 22.85, 85. The second last one is 23.0, and the last one here is 23.71. Okay, so these are the total number of data points what we have, and these are 20. So how to find out the mid value here? What do we have to do? We have to find the two mid values, and we can see that these two values are basically this 10 and 11, and at this instant we can see that these are the two values, and we can see that here 1 2 3 4 5 6 7 8 9 9 values at the left hand side, and we have 1 2 3 4 5 6 7 8 9 9 values at the right hand side. Okay, so what do we have to do? We have to take these two values, because we have now even number of data points. In previous question we had the odd number of data points, and here and there we just have taken the midpoint. Here we have this number. So what do we have to do? We have to find the median. In order to find this median, what do we have to do? We have to add these two numbers together. So that is 20.50 plus 20.72 and divide it over 2. Okay, so from it what will we get? We will get the answer, and that is 20.61, and that is the answer of our question which we had to find out the median. Okay, so that is the answer of median. For the other question, for the other parts of this question B, C, D, we will try to solve them in our upcoming video. So in this video we have talked about the median and mean of the data points which we have here. So we have 20 data points here. For them we have calculated the mean and then median of these numbers. So what is basically the part P? We have to compute the 10% trimmed mean. Okay, so in this sort of question, what do we have to do? We have to drop the lower 10% and higher 10% of our data sets, and then we have to calculate the mean of it. Okay, so let me remove the previously studied mean and medians. Let me remove it. So I have to use the name for it, and that is mean underscore tree r, and here we have to add all the data points which are here, and these are from 18.9 to 19.25 up to the 22.85. Okay, so let me add them. 18.92 plus 19.25, okay, plus 19.29 up to what? Up to the data point, the last one here is 22.85. okay, so after adding them I have to divide it over what? The two data points from the lower end and two data points from the upper end has been removed, so the remaining data points we have are 16. So therefore the data points we will have will be 16. So as I have already calculated it, and the summation of it is 331.89 divided by 16, and finding it, the trimmed mean of it will be what? 20.743. Okay, so what is this? This is basically the trimmed mean. Let's go TR, and the value of it is here, and this is the answer of a trimmed mean. So what is this? This is the actual mean, this is the trimmed mean, while this is the median of our data which we have previously calculated. So these are the values. In our part C, we have to do a dot plot of the absorbency data. So the dot plot of it, we will do it in our upcoming video. So now let me see that what is part D asking. So part D is asking me that using only the values of the mean. Okay, this is the value of the mean. Median, this is the median, and the trim mean. Do you have any evidence of the outliers and the data? As we can see that these three indicators basically have been showing me very less amount of difference in between them, because these are almost similar. So therefore it is not showing me or not indicating me the availability of any outlier. So therefore the answer of it is no, because these are basically the similar ones. If I had a higher difference between the mean trimmed mean and the actual mean, so basically it would have indicated the availability of any outlier here, as we have removed the 10% data from it, and we can see that still these two measures are almost similar. So it is not showing me the availability of any outlier here. Okay, so that's it for today, in which we have discussed the three parts of our question 1.2. So I hope it's enough for today. We will also try to solve the part C in our upcoming video, but the actual concept is similar as we have previously seen in our question 1.1, and you can also try to solve the same part as we have done it. So this is question 1.3 of our book, which is Introduction to Statistics and Data Analysis. Okay. So let me read this statement here. So a certain polymer is used for evacuation systems for aircraft. It is important that the polymer be resistant to the aging process which occurs with the passage of time. Okay, so 20 specimens of the polymer were used in an experiment to test the aging and tensile strength. 10 were assigned randomly to be exposed on an accelerated batch aging process that involved exposure to high temperature for 10 days. Measurements of tensile strength of the specimens were made, and the following data were recorded on tensile strength in PSI. Okay, so this data is for non-aging and aging as well. These are the 10 specimens for the aging and non-aging tensile strength of the polymer. Okay, so what is part A? Today we will concentrate over a dot plot of the data. So here we have this data for the aging and non-aging, and let me solve it for part A. Okay, so in part A, what do we have to do? We have to do a dot plot of the data. What we can do for a dot plot, we can plot it over a single plot for the aging and non-aging data, and also use the separate plots for them as well. So let me use a same plot for them. So in using a same plot for them, let me have here this line, and let me start it here from 200. Okay, let me take this data from 200 up to 230. Okay, so this is what, this is the range of our data, and let me have here at the middle of it I have 215. Okay, here I will have 208. Let me have 208, and here I will have 2222. Okay, this is the data. Let me use other that's here as well. So this is 204, this is 208, and let me have here 211. Let me have 211 here, 218 here. So let me have 218 here, and also here we will have 206. So these are different data ranges here. So for plotting them, let me use different colors for them. So for aging, I am going to use this color. Sorry, for the non-aging, I'm going to use the red color, and for the aging, I'm going to use this one. This is cross and this is dot. For them, I'm going to try them here. So the first data I'm going to plot here is for the non-aging, and the first point here I have is 227, and that 227, sorry, this is 226. Yes, this is 220. Okay, so the first data I have is 227, and let me have it. Okay, so this is 227. The second one is 222. This is here. The third one 218. This is here. Okay, fourth one 217. Let me have it here. And then 225. So 225 is somehow here. Okay, the other one is 218 again. So let me draw it here. The next one is 216. So 216 almost lie here. Okay. Then 229. So 229 lies here. Okay. Then 228 lies here, and the last one here is 221. Okay, which lies. So this is the data for what this is for the non-aging tensile strength, and we can see here that all the data is mostly related to the higher aging in years, because we can see that all the data has the highest strength, which can be seen here the through the skewness of our data, which is mostly skewed toward this maximum range. Okay, so after it, let me draw it for the aging data, and for it I have selected this purple color. So the first data point is 219, and 219 is somehow here. Okay, the other one is 214. It is here. 215. Okay, it is here. 211 here. 209 here. 218. Okay, so it is here. 203. So 203 is here. Okay. 204 here. 201 here, and the last one is 205 here. Okay, so here we can see that more of the aging data basically lies here. Okay, so let me use this color, that we can see that most of our aging data basically skewed toward this end. Okay, so this is for the aging concentrated data. All the aging is concentrated over here, while we can see that for the non-aging data, which is represented by this blue color, that is mostly concentrated over this area. Okay, so we can see that this is the concentrated non-aging. So most of the data here skewed toward this one, and from this plot we can very clearly see that the tensile strength increases with the non-aging. Okay, so as the data is newer one, or as the polymer has the newer specimen, their strength is higher. As the polymer has less age, its strength is higher, while the polymer samples which has the higher aging has the lower strength. Okay, so that is shown by this dot plot. Okay, so I hope you have understood the underlying concept of the dot plotting, and I hope it will be useful for your data analysis and statistical knowledge. So what is part B here? Part B is asking us that from your plot, does it appear as if the aging process has had an effect on the tensile strength of this polymer. Explain. Okay, so the same point has been explained in our previous video. Let me explain it again. So in blue we can see that we saw that most of the data which has the tensile strength or higher, because that is the aging data, and the aging data which is in purple here, we can see that that is mostly skewed towards the lower tensile strength, while the data which has lower aging has the higher tensile strength, which can be seen here. Okay, this is the tensile strength in PSI. So we can see that this plot has shown us the aging process had an effect on the tensile strength, because the greater the age, lower the tensile strength of the polymer. Okay, this plot shows us. Similarly, in part C, we have to calculate the sample mean tensile strength of the two samples. Okay, so this is part C. Let me have here part C, and in order to find the mean of, let me find the mean of the non-aging NA, what do we have to do? I have to add all these samples here. Okay, so I have to add 227 plus 222 plus 218 up to the last one, which is here 221, and divide it over the total number of samples we have. So here we have 1 2 3 4 5 6 7 8 9 10 divided over 10. Okay, so I have previously calculated it, 2221 divided by 10, which basically give me 222.1. that is the mean tensile strength of my data. Okay, if we have a no aging process. Similarly, for the mean of the aging data, let me use this one here, and now adding all the points which are here, what would I get? This would be 219 plus 214 up to the last point, which is 205. Okay, and again dividing it over the total number of points here, and these are 10. Okay, so as I have already calculated it, and that was 2099, and dividing it over 10, what I will get? I will get 209.9, and that is the mean tensile strength for the aging data. Okay, so we have these two mean values for our data. Okay, so we have calculated it, and we can see that there is a huge difference between them. And here if we plot it by it, we can see that for the aging process, the mean for the no aging process, okay, the mean value lies almost here. Okay, it almost lie here, while the mean of the aging data basically lies almost here. Okay. So the mean tensile strength of the no aging data is higher as compared to the aging data as well. So this is also a measure of the average tensile measure, that which data has a higher tensile measure, and that can be reflected by these values. Okay, so this is the data for it. Now let me move towards my last part of this question. Okay, and what is it? We have to calculate the median for both. Okay, discuss the similarity or lack of similarity between the mean and median of each group. Okay, so in order to find the median of it, what are the steps? Okay, so in order to find the median, we know the steps, and in step 1 we have to sort our data. Okay, so in sorting them, let me have here no aging data, and the sorted no aging data here is, I have sorted it already, so it is 216, 217, 218, 218, okay, 221, okay, 222, We have 222, 225, 227, 228, and the last one here is 229. This is for the no aging data. For the aging data, what do we have here? We have here 201, 203, 204, 205, 204, 205, 209, 211, 214, 215, 214, 215, okay, 218 and 219. Okay, so here we have this data, and we can see that the total number of points in each data set, these are basically odd. So in finding the median of the odd data set, what do we have to do? So we can see that the total number of points here we have in both of these data sets are 10, which is basically an even number. Okay, so in order to find the median of the even numbered data set, what do we have to do? We have to take the middle two numbers, because in middle two numbers the total number of points at the right and left side will be equal. So we can see that here 221, 222 are the middle two numbers, because here we can see that 1, 2, 3, 4, 4 numbers are at the left side of it, and also 1, 2, 3, 4, 4 points are at the right side of it. So in order to find the median of it, what do we have to do? I have to take them, okay, and find the middle of them. So it will be 221 plus 222 divided by 2. Okay, so what will I get? By adding them and dividing it over 2, I will get 221.5, and that is the median value for the no aging, which is also the mean having it here. Okay. Similarly, for the same data set, we have the aging data, and here we can see that the two middle points for the 10 data points here is this one, and in order to find the median of it, again we will take these two numbers, okay, add them together and divide it over 2, and what I will get here? I will get here 210, which is the median for the aging data set. Okay, so we can see that there is these 2 points. Okay, this is the mean, while this one is the median, while we can see here that this is the mean, this is median, and we can see that these are almost similar. There is a lot of similarity in between them, and the answer of it is that discuss the similarity or lack of similarity between the mean and median of each group, and we can see that the mean and median are almost similar, which shows us the unavailability of any outlier. So that is the solution of our question, in which we have not only plotted our data previously, but in today's lecture we talked about the detailed explanation of the previously plotted data, calculated the mean tensile strength of the aging and non-aging data, and also calculated the mean for both of these data sets. So I hope it is clear now to you guys that how to calculate different quantities for the data set which we have, and finding the insights into that. Today we are going to solve the question number 1.7 of our book, and in that question we are asked to find the standard deviation or variance of the data set we have here. Okay, so we have here the data set, and in previous videos we have found out the mean mode of the data set which we have been given, but in real science, in real life data science, machine learning and all the data driven models, it is not always possible for the mean to convey us the information for the viability of any data set. Okay, so if it is not giving us the required information, then we have to move towards another moment, and that is basically the variance. Okay, so I have previously told you that we have the first moment, and that is the mean. Mean is the first moment. If mean is not giving us the required information, then we have to move to the second moment, and that is variance or standard deviation. Okay, so today we have to find out the variance of our data set, and for it, let me move down here. Okay, so this is basically the data set we have. And here, in order to find out the variance for it, variance is usually represented by S square. In order to find it out, what we have to do, we have all these data sets. We have to take any data set here. From it, I have to subtract the mean. Okay, take its square and divide it over the number of points minus 1. This is basically the formula for it. After it, as we have many points here, so what I have to do, I have to subtract mean from each of these points, which are xi, and this I starts from the first data point and ends at n. So all the data points which we have here, we have to subtract mean from it, square them, and then add them together, and at the end what we have to do, we have to subtract, we have to divide it over n minus 1. Okay, so that is basically the formula for the variance of a data set, okay, which basically shows us the average spread of the data. Okay, similarly, what if we want to find out the standard deviation from it, what do we have to do? Let me use this color for it. What we have to do for finding the standard deviation, we have to what? We have to square root it, and it will ultimately give me S, and here this S is basically what? This is the standard deviation. Okay, so we have to do it. So now for the same data set, we have to find out the variance and standard deviation. So let me start it here. So for it, our data here is, let me find S square. So data we have is 2.5. The first point is 2.5, and do we have a mean for this problem? We can recall that here we have already found out mean of our data, and that is here 3.79. okay, so let me use this mean here. 3.79 is the mean, and I have to subtract this mean from each of the point which we have here. So 2.5 minus 3.79, okay, and then square it. The second point here we have is 2.8. So I have to take 2.8 minus mean of it, and that is 3.79, and then square it. The third point here is again 2.8. So then again 2.8 minus 3.79 whole square. Okay, and then from it I will do it for all the points which are here. Again 2.9 minus 3.79, 3 minus 3.79 up to 5.6 minus 3.79. So what I will have to do, I will have to do it for the 5.6 minus 3.79 and then square it. Okay, so what is the second step here? We have to add these square parts. Okay, and after adding them, I will have to add it over what? Add it over n minus 1. So how many points do I have here? N is basically what? The total number of data samples. So n is what? Total number of data samples. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 data points. So 15 minus 1 according to this formula I have to do it. Okay. So after carrying out all the operations and adding them together, what I will get, the value of s square will be what? So it will be 0.942. Okay, so this is what? This is the value of the variance which we had to find out. Okay, after it we also have to find out the value of the standard deviation. And in order to find it out, we have to take the square root of s, and that would be 0. That would be what? 0.942. Okay, square root, and if we calculate it, we will see that it will be 0.96. Okay, this is what? This is the value of the standard deviation, which is usually represented by s. So that's what, by using which we can find out the value of the variance, the value of the standard deviation, and this is the methodology of doing so. Okay, this is the called the second moment. Let me write it here. Second moment. Okay. First moment is the mean, second moment is the variance. Okay, so this is question 1.13 of the introduction to statistics and data analysis, and here we have to analyze another data. So what is the statement here? A manufacturer of electronic components is interested in determining the lifetime of a certain type of battery. Okay, so he has the manufacturer of an electronic components had developed a sort of battery, and he wants to determine the lifetime of the battery. A sample in hours of life is as follows. Okay, so there are different samples which he has found out. So what do we have to find out? We have to find the sample mean and median. Okay, so this is part A, and in part A we have to find the sample mean and sample median. Okay, so here we have to find the mean. So mean for it is what? That would be the sum of all samples divided by the number of samples. It would be what? We have to add all the numbers which are here. So I have to add 123 plus 116 plus 122 up to what? Up to 117, which is the last part here, and divide it over the total number of points. So let me count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 total number of points. Okay, so let me add them, and in adding them I will have 123 plus 116 plus 122 plus 1110 plus 175 plus 126 plus 125 plus 111 sorry plus 18 plus 117, sorry, minus 117, and now plus 117. So that is 1243. Okay, so here I will have 1243 divided by 10, and the answer of it will be 124.3, and that is the mean of 124.3 hours is the mean value of the battery life. Okay, similarly we have to find out the median, and in order to find the median, the first step is to sort the data. So in sorting the data, let me look for the smallest number, and that is 110. 110. The second one here is 111. So 111. The third one here is, let me see that, what is the third one here? So that is 116. 116. Okay, here 117. 117. Okay, then 118. 118. Okay. Then after it, here we have 122. 122. Then 123. Okay. Then 125. Then 126. 125. Then 126. Okay. And the last one is 175. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 numbers. So what do I have to do? Again, I have to count the number of points. So here we have the even number of points. So therefore I have to select the mid two numbers. So I have to select the mid two numbers. Therefore, removing the 1, 2, 3, 4, 4 numbers from the left side and 4 numbers from the upside, because we have here the 10 number of points. So therefore the remaining numbers here will be these two, and we can see that 118 plus 122 are the two numbers. I have to add them and divide it over 2. So what I will get, let me use the calculator here, and here I will have 118 plus 122. So that is 240 divided by 2, and it would be 120. So the median of my data is what? That is 120. Okay. So that is the of my data. This is the mean and this is the mean. Okay. Here we can see that the part B here is what features in this data set are responsible for the substantial difference between the two. Here we can see that this is 124.3 while this is 120, which is basically the higher difference between these two, which should be equal in length and which should be almost equivalent. Okay, and that is because of this 175, which is called the outlier. Why is it outlier? Because we can see that there is a very slight difference between each of the consecutive entries up from 110 to 126, while the difference between 126 to 175 is almost 49. Okay, so the difference is higher, and that's why this one is called the outlier. And adding it over here, it is basically giving us the dispersion of the median from the actual value. Okay, so therefore there is a difference between the mean and median, that is because of this outlier. So I hope the concept of the data analysis from this question is now clear, and I hope you will understand the concept of outlier from this question, that how to tackle down the outliers. It will be the topic of our upcoming videos. So this is question 1.14, and here we have to analyze some data based on the statistical concepts which we have previously revised. So a tire manufacturer wants to determine the inner diameter of a certain grade of a tire. Okay, so ideally the diameter would be 570 mm. So this is the ideal diameter of a tire. So the data are as follows. So he has taken some data points, and these are here which are mentioned. So what do we have to find out? We have to find the sample mean and median. So this is part A. So let me start it with part A, and here in order to find the mean of it, we have to add the data here. So adding all the data points, 572 plus 572, then 573, okay, 568 plus 569 plus 575 plus 565 plus 570. Okay, so this is all the data which I have to add together. So 1 2 3 4 5 6 7 8 data points here. So therefore after adding them, what do I have to do? I have to divide it over 8, okay, which is the total number of data points which we have. So let me add them together, and here adding them, what I will get, let me add them together. So here I have 570, 572 plus 572 plus 573 plus 568 plus 569 plus 575 plus 565 plus 570. So what will I get? I will get 4564. Okay, so I have here 4565, and after it I have to divide it over 8. Okay, so how much would I get? So let me again go to the calculator, and here dividing it over 8, what I will get here, it will be 570.5. okay, so it is now what, 570.5. okay, so this is what, this is the mean diameter of the samples, and this is in what, this is in millimeter. So this is the mean. In order to find the median, what I have to do, I have to first sort the data. So let me sort it first. So here, in order to find the median here, let me first write the smallest number. So the smallest one here is, the first one is 565. So writing here 565. The second smallest is, let me see, this is 568. okay, 568, then 569, 569, okay, and then after it 570, 570, after it 572, 572, 72, then 573, and the last point here is 575. So this is the highest point here. So we have this data, and here we can see that the number of points here, we have 8. So therefore I have to take two mid numbers and finding the mean of it. So removing the highest three numbers and the lower three numbers. Okay, so after removing them, we will have 570 and 572, two mid numbers. What do I have to do? I have to take these two numbers, and median of my data point will be, so now here what I will have, I will have 570 plus 572 divided by 2, which will give me what, which will give me 571. okay, so the median of my data point is 571 millimeter. So this is what, the part A of my question asks. Okay, so in part D, what do I have to find out? I have to find out the sample variance, standard deviation, and range. Okay, so this is part B, and the first thing, let me find out the range of it. So what is range? Range is the largest data point in the data set minus the smallest data point. So the largest data point which we can see here is 575, and smallest is 565. So let me write 575 minus 565. I will get here 10. So the range of it is what? Range is 10. Okay. So the range is 10 here. So in order to find the variance of our data set, this is variance. The formula here is that we have to add all the data from I equal to 1 up to n, and in that data what do I have to have? The data points we have are xi, which are starting from 1 up to n, and in each of this data we have to subtract the mean from it. Okay, so the mean here is what? Let me write here first mean. Okay, and then I have to add them together and then dividing it over n minus 1. Okay, so we can see here that what is n? N is the total number of data points we have here. So let me write n equal to 1, and here we have mean is given, and similarly the value of n is what? We can see that it is 1 2 3 4 5 6 7 8. So it is 8 here. Okay, so let me write all values here. So variance will be here what? It will be I equal to 1 up to n, and xi minus the value of mean is 570.5. Okay, so subtracting it and also squaring it. So I have missed it. I have written it here square here as well. So let me write all these data points here. So variance of it will be, the first data point here is 572. So 572 minus 570.5. Okay, squaring it. Okay, and then adding with it another data point, and that is again 572. You can see that 572 minus 570.5 and squaring it. Okay, then adding with it the third data point, and that is 573. Okay, so 573 minus mean, so 570.5 whole square, and adding with all the points which we have here up to the last point, and that is 570. So 570 minus 570.5 whole square. Okay, so this is what we have. We will add them together, and after adding them together, what would I do? I will also divide it over n minus 1, and n is what? 8, so it will be 7. Okay, so after calculating it, what I have got? I have got the value of variance is 10, and this is what? This is the answer of my question. Okay, so this is for variance. And similarly, in order to find the standard deviation of it, so standard deviation is the square root of variance. Okay, so let me write the value of 10 here, and to calculate it, what I will get here? I will get here, let me find the, and that is what? That is 3.16. 3.16, and that is the value of the standard deviation, which is the okay. So the last part here is part C. So using the calculated statistics in part A and part B, can you comment on the quality of the tires? So the average quality of the tires is almost similar, as we have previously seen that the perfect quality is 570 millimeters. So the mean quality of our tires is 572.5, and the median of it is 571, which is almost near to the 570 millimeter. And also we can see that the variance is also higher. We can see here that the mean and median values are also almost nearer to the perfect quality, while the variance is quite high. Okay, this variance is higher, which is basically showing me that the average spread of the samples is quite high as compared to the perfect value. So that is now questionable. This is now showing me that first moment is not going to tell me any characteristic of the data that is basically showing you the perfect characteristic of the tire, while variance, which is the second moment of the data set we have here, is basically showing me the highest or the higher amount of average spread available in the data. So which is not consistent. The quality of some samples is lower, the quality of some samples is higher, so this is questionable. So that's it for today, in which we have seen the statistical analysis of the tires made by the tire manufacturing company, and on the basis of the diameter of the tires we have calculated the parameters which are mean, median, variance, standard deviation and range of it. And today we are going back to the chapter number 1, and here we have to solve some questions which are starting from question 1.18. okay, so the question here is: the following scores represent the final examination grades for an elementary statistics course. Okay, so these are basically the scores, and the total number of scores we have here are 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6. So these are 54, 55, 56, 57, 58, 59 and 60. So we have 60 data points here, and it is not easy for us to write them all here and then add them, and it will be somehow hectic for us to add them all. Okay, and finding the sample mean, sample median and sample standard deviation will be harder for us to find here. Okay, so till now we know that what is mean by mean. So we know the formula for mean, and that is basically the addition of all the numbers. If we have numbers which are represented with x with an index of I, and these are starting from 1 and moving up to n, where n are the total number of elements we have, and then dividing them over n, it will give me mean. Similarly, after it we can also find out the median of it by first sorting it and then finding the midpoints, okay, of data points which we have. And the standard deviation we have here is that is basically the square root of variance, where the variance is what we know that the variance is basically all the data points minus what mean of it. So mean and then squaring it. Okay, and at the end adding them all together from 1 to n and dividing it over n minus 1. Okay, so this is what this is for mean, and this is for variance. Okay, and we can very easily find out the standard deviation out of it by taking the square root of it. So that is what we have to find out, and we have done it in our previous question. But here, as the number of points are greater, so it is more feasible for us to use any programming environment, any packages which we can use to do so. Okay, so therefore in today's lecture we are not going to solve this question by hand, but with the help of the Python we are going to solve it. Similarly, in part A here, we also have to construct a relative frequency histogram, okay, and draw an estimate of the graph of the distribution and discuss the skewness of the distribution. So we are also going to discuss that what is mean by the histogram, what is basically the estimate of the distribution, and what is a skewness. Okay, we are going to talk about them all. Okay, so before going to discuss them all, let me remove it first. Okay, removing them, we know these formulas and we have them here. Okay, so first of all let me see that what is a histogram. Histogram, so histogram basically shows me a plot where the relative frequency or the frequency of the occurrence of any data sample is shown. Okay, so suppose I have a data. Okay, and in that data I have some points which are basically 1 5 2 1 3 2 5 1 3 5 and 4. Okay, so here we have how many points do I have here? I have here 1. Okay, I can see that these are starting from 1. I have here 5. 5 is here as well. Okay, Do I have here 2? Yes, I have here 2. This is 2. Okay. I have here 3. Let me use this for 3. I have here 3. And I also have here another data point, which is here 4. Okay. So I have different points here. Let me write them all together. So I have here, let me write it with red. I have here 1, and the number of times 1 has occurred here is 1, 2, 3. Okay. So the frequency of 1 is 3. Okay. Similarly, I have here 2, and I can very easily see that it has occurred 1 to 2 times. Okay. So therefore 2 has been occurred how many times? 2 times. Okay. Similarly, I have here 3. Okay. This is 3, 1, 2. It has been occurred 3 times. Sorry, 2 times. So therefore that is now 3, and 3 has occurred 2 times. Okay. I have here 4 as well. So let me write here 4, and it has occurred 1 time. So 4, and the occurrence of it has 1 times. And the last data point I have here is this 5. So it has occurred 1, 2, 3. Okay. So 5 I have, and it has occurred 3 times. Okay. So this is the relative frequency of all the data points which I have here, and in order to plot them all, I have to use a type of the plot which is called what? Which is called the histogram. Okay. So let me plot it here in order to show that how it works. So the histogram I have here is just like here. Okay, so let me move somehow here. Okay, so on the x-axis, what I have to do, I have to write all the numbers which I have here. So I will have here 1, 2, 3, 4, and 5. These are the numbers which are here we have, and here we have 1, 2. So in order to show that how many times these have been occurred, we have to write here the numbers, and here their frequency, that how many times these had occurred. So the first number is 1, and 1 has occurred 3 times. So let me use this red plot for it. So it has occurred what? 3 times. So here we have this for this 3. Okay. The second number is 2. This is 2, and it has occurred here. Let me plot it here. Okay. So this is 2. The third one is 3. Sorry, this one. So this one is 3, and the frequency of it is also 2. So let me draw it here as well. Okay. This is 3. The fourth one is 4. So 4 is represented with this, and it has occurred 1 time. So 1 is here. Okay. This is here, and the last one is 5, which has occurred, or the frequency of it is 3. Okay, so let me plot it with this yellow color because it is represented with this. So here it will be here. Okay, so that is what this is basically called, the histogram. Very beautiful plot which shows me the frequency of the occurrence of different elements, and the this it is basically what this is also called distribution, or the discrete distribution, and that is basically the discrete distribution, which is the histogram. And in order to see the estimate of the graph of the distribution, what do I have to do? I have to plot here, or I have to use here what? This is basically the estimate of this distribution. Okay, so this is basically the estimate of this distribution, and here we have it. We will discuss skewness of in our upcoming lecture, but skewness is what if a data point has been tilted to some other data samples, so that is basically skewed towards that point. So suppose if I have here a distribution which is just like here, so I can see here very easily see that these data points are more skewed towards this point, and that is basically this one, and here this is more skewed towards right. So this is skewed data. Similarly, if I have another distribution which is just like here, okay, so we can see here that all the most of the data samples are concentrated over here, and this is therefore called the left skewed. Okay. So we have seen that this is the skewness. So the in our previous videos we have discussed some moments of distribution. Okay, the first moment we discussed was the mean. Second moment was the variance. Third is basically the skewness. There is also another moment as well that is called kurtosis, but I am not going to discuss it here. But what are these moments? So in many scenarios, calculating the mean is the first and the foremost point of finding the insights of out of a data samples, but in most of the scenarios mean doesn't provide me the information which I need. So therefore I move towards the variance, but variance basically shows me the average dispersion or average spread of a data samples which I have. So in most of the other scenarios it doesn't also provide me the information which I need. So therefore we also have to move towards the third moment, and that is basically the skewness. Okay, so skewness is the third moment which is related to all the information which the data which should provide me. So that's it for today, in which we have discussed the concept of the histograms on all the things which we have to do in the Python and in the data samples, where the number of samples are increased such that these are not handled to be manipulated by hand. Okay, and some computer related programs are required at that point. So that's it for today, and I will see you in our upcoming video with the Python equivalent of the relevant calculation. Thank you so much, and I will see you soon.